In this video, we are going to look at waveform roughing. Waveform roughing strategy is a high-speed machining technique that maintains a constant tool cutting load by ensuring the tool engagement into the material is consistent. The tool path moves in a smooth path to avoid sharp changes in direction, which maintains the machine tool's velocity. As waveform maintains a constant engagement, the feed rate can remain at the optimal value throughout the cycle. This will improve the tool life and greatly reduce the risk of tool breakage, and particularly beneficial when cutting hard materials. To show how this strategy of roughing can be carried out, let's first create a geometry, as we can see here. Select a tool for roughing the part and apply the relevant tool directions. From the machine ribbon, select Pocketing, and while on vertical milling, tick the box that says Use Z Contour Roughing. You can see the dialog has updated to show the pattern or strategy of machining. Set your required Z levels. Select the geometry to machine. Here we can now see the waveform roughing strategy has been applied. In the simulation of the part, we can now see the tool feeding into the material and the tool path moves in a smooth path to avoid sharp changes in direction, which maintains the machine tool's velocity. Cutting along as much of the flute length as possible distributes wear evenly along the entire flute length, rather than just the tip. The radial cut depth is reduced to ensure consistent cutting force, allowing cut material to escape from the flutes. Tool life is further extended as the majority of the heat is removed in the chip.
Designer is Vero's powerful new CAD for CAM application. With its clean, new interface, the ribbon toolbar, and the quick search, it's easy to navigate and find the functionality you need. The contextual help available with every command makes it easy for anyone to get started. From the backstage, you can view recently opened parts and folders. The structure tree will help to manage larger parts or assemblies, and views can be managed from the head-up display toolbar in the graphics window. You can import models of many different file formats into Designer. This can often require some form of model fixing. Direct modelling means we don't have to deal with complex history trees and the rebuilding of parts. We can do model repair, fix solids, surfaces, or wireframe as if they've been created in Designer itself. Designer is being marketed for the CAM market for our customers. Core functionality is tailored toward being able to take existing CAD models and preparing them for manufacture. Hole capping is a key part of this. Designer automatically caps multiple holes quickly and easily. Direct modelling can be applied to lots of different model types, making it applicable across the diverse range of manufacturing environments that Vero operate in. The measurement tool, alongside intelligent snapping, enables us to have complete control when manipulating our parts. In Designer, you can quickly turn a 2D drawing into a 3D solid model. The combination of the structure tree and the fresh new interface make it easy and intuitive to manipulate your geometry. By extruding regions, Designer makes light work of complex solid creation. And direct modelling quickly allows edits to be made to the part. While a lot of the core functionality is applicable to general machining and metal milling, more advanced CAD functionality enables us to create complex geometry for our brand's specific areas of excellence. Extruding a profile along a drive curve creates a solid handrail for our woodworking customers. Designer makes light work of fixture creation. The direct modelling capabilities gives us the freedom to pull and push the model around until you get the desired result. Clearance is easily added and any unwanted features removed. Often supports are required, so these can be added where necessary. Pre-existing parts can be added to complete the fixture. Regardless of whether you work in the woodworking, sheet metal or metalworking industries, Designer from Vero will be able to increase your productivity and efficiency.
My name is Mario Romano. I'm a designer and maker here at Romano Studio in Santa Monica, and we're also known as MR Walls. We make 3D textured surfaces using solid surface Corian. Our background is construction and design and building incredible houses, and we've designed and made some really complex houses and homes in Santa Monica, in Venice. And we love pushing the design architectural language.
They're identifiable. You know, someone sees our surface and they know it's us.
We have our wonderful patterns, but what we can do is someone has a logo or maybe just an aesthetic or a feel that's for their business or for their apartment complex or their lobby, and so we can use that, we can incorporate that into design.
When we find out that another fabricator or machinist has AlphaCam, we are relieved. We know immediately that they'll be able to process our files and read something that's specific. It's called 3D line work or 3D geometry.
If it's going to be produced here in Los Angeles, we'll order the material here and produce it and ship it locally. But let's say something's in Australia or somewhere in another part of the country, we will send the file to one of our fabricators nearby that location. They will fabricate it and then ship it there, so we save on shipping costs, we save on time.
AlphaCam, it's a great program. For a lot of our fabricators around the world, it's really easy for it to read our line work. It can read the Z and all these different axes. It's user-friendly for our fabricators around the world, and it just makes it easier for us to translate, to talk to them through all the processes and all the steps.
The AlphaCam allows for a very high level of expression. Machining and CAM is a universal language, which is really wonderful because we've worked with partners who don't speak English, and we don't speak their native language, but we actually speak the same language of building science, of CNC machining, and if they have AlphaCam, then it makes our interpretation or translation process even easier and more efficient. Part of our design process is to have a variable Z depth that's changing throughout the line work, and AlphaCam solves that. It reads that, and that's fantastic. It also has a really great simulator. It's very robust. Great support, and we love being a part of that. We feel very much a part of this AlphaCam team, and it boosts a lot of confidence because we're not having to solve a problem for someone else because they have another CAM software, and that's happened before and it can be very frustrating. Nature is an inspiration for all of mankind since perpetuity. We're trying to continue to create logic that works in the way nature does, so it creates mass variation.
I like the duality between being on the computer and then also being able to touch and feel the material that we're working with. We have a CNC here in our studio, so it's really nice kind of having both to play with. I can visualize something in my mind, draw it on the computer, and use AlphaCam to translate it.
What does it mean to be a maker? The maker is a wonderful word because the maker, what it means to us nowadays is that the maker is the designer and the maker. What we're trying to do here is instead of mass production, we are into mass customization or mass variation.
I'm working on something that I can touch, and that's it really feeds the soul. It becomes a part of us, and there's something that's so fulfilling about that I don't know, I can't even begin to describe it.
So the backlighting is super magical. It's probably like our wow factor. You know, people just are super excited when they see it. You know, they've never seen anything like it before. By tinkering with the depths, with the variable Z, we're able to really carve the light and express what we want to express. We worked with this really cool artist. His name is Nate Moeller. He's like a digital artist, so he does projection mapping. We were able to provide a solution. He wanted something that was thermoformed. He wanted something in a tube format. If someone hashtags Culver City, you know, puts a little blip or whatnot and changes the pattern, so it's always, you know, it's always variable. We prefer our manufacturers around the world and locally to use AlphaCam. It makes it really easy for our designs to be translated.
We look at CNC machining as like paintbrushes, right? Or as like a machine to help us sculpt and carve. When you carve something, there's something instinctive or primal that is awakened, where you're etching into a wall. And what does that mean? It means it's permanent. It's a way of communicating.
NC-Sim is a software that helps manufacturers who are not satisfied with the overall equipment effectiveness of their machines in order to improve their usage rate. As you know, using the real machine for proving out programs is a waste of time and can generate machine crashes that represent between $20,000 and $50,000 in repairs, not to mention the time spent to rebuild the machine. NC-Sim validates the final code, also known as G-code, and replaces the final test that's usually done on the real machine before production. NC-Sim complements CAM systems, connecting to more than 15 of them on the market, and will simulate any type of CNC machine. Proving out programs on the real machine represents a high cost for the shop floor. For example, if you do a simple calculation of return on investment for 10 machines with 8% of their time devoted to proving out programs and 2 8-hour shifts a day over the course of a year, it equates to a cost of $250,000. Therefore, proving out programs offline with NC-Sim can facilitate an impactful annual cost reduction. Here are 6 reasons why NC-Sim is better than the competition. First, NC-Sim is easy to use. It is built with the familiar tabs and icons setup that you'll find in Microsoft Office solutions. Each icon has a use and each function has an icon. Secondly, NC-Sim is founded on a 3-step process. Step 1, G-code decoding. It can detect syntax errors, programs inconsistencies, such as cuspidal point errors on cutter compensated toolpaths. Step 2 is the simulation, which can detect anything causing a collision or contacting the non-cutting portion of the tool. It is exactly what you do on the real machine when you single block your G-code program. This replaces having to use the machine to test for collisions. And step 3 is called dimensional analysis. It's exactly what you do on the shop floor when you measure the part after the first piece is made. You check to see whether you've forgotten tool offsets or if features of the part are out of tolerance. And those are the 3 steps that drive the G-code validation for programmers. NC-Sim's third advantage is being able to validate machine macros in their entirety. Unlike the competition, NC-Sim will read the macros that are in the memory of the real machine and use those macros during validation. The fourth advantage is that NC-Sim is fast. Using the latest OpenGL technology developed in the 2000s, NC-Sim can process more data more quickly than the competition. The fifth edge NC-Sim possesses is the clarity of view from start to finish. When you move the part on the screen, there isn't a visible refreshment time. Whether you are in machine or part view, there isn't any pixel refining in the way that you may observe with the competition. And lastly, you can be easily trained on the user-friendly interface of NC-Sim in just 2 days. You will be able to simulate all of the machines in your workshop in less time than it often takes to validate a single part. For any digital twin loaded in NC-Sim, it's possible to enter the machine motion to view both the direction and the range of each axis. Right-click on the machine and choose Machine Axis Movement. Choose the visibility of the machine enclosure and then an axis to move. For example, you can verify which direction the Z positive or negative values are taking, where to position the tailstock to avoid collision with the tool station, how much to extend the quill to contact the stock, the steady rest position, and the opening and closing of the clamp, or even if any of the tooling loaded in the turret is going to collide with any of the aforementioned features, the chuck, or the back of the machine. Additionally, you can call a specific G-code that the shop is using, such as the G28 here, and jump all axes to this alignment. Stepping through the axis motion can allow for easier visualization of the machine movements, especially on machines that are tough to see inside, speeding up the time to produce a final part. In addition to using the 3D models of the machine, inside NC Simul you can create your own collision boxes. These can be used to add accessories, warning areas, or reduce complexity in non-important areas such as these holes in the spindle. To do so, find the machine in question, right-click it, and choose Properties. From here, you can access NC Motion, the machine building tool, from the Kinematics button. Upon opening, you'll see a tree on the left-hand side with the axes and their dependencies on one another. In this case, we're going to modify the spindle, which is found to be on the y-axis based on the highlights in the 3D window. Right-click it and choose Properties, and then More. Inside here, you can see the axes limits, the 3D models associated with the axes, and the ability to add collision objects. There are 3 layers created in this example, one for each segment on the y-axis, and just made with simple cubes. For each, you can increase or decrease the X, Y, and Z values to adjust the size of the collision box area in the same directions as the machine axes would move. You can also reposition the entire cube to wherever you'd like in space and recolor it for clarity. Once satisfied, apply the changes, save the machine, close NC Motion, and head back into NC Simul. Now, anytime another part of the machine, a tool, fixture, rough stock, part, or accessory violates the new collision areas, NC Simul will automatically throw an alarm, making sure that your G-code is completely safe before running it on the real machine. NC Simul has the capability to simulate probing cycles, including those checking for tool height, radii, or breakage. When called, NC Simul can perform the tool change, including all arm motion. Then, once complete, it can head to the tool probe location and touch off on the probe before returning to the home position and beginning the machine simulation. By checking this before the material removal begins, you can alleviate the risk of crashing because of an incorrect or broken tool in the spindle. This can be implemented for both milling and turning machines. In addition, the rough stock can be probed, the points recorded, and the program origin adjusted accordingly, just like at the real machine. This example also simulates the opening and closing of the tool change doors, as well as the extension and retraction of the tool probe touch-off. The different probing strategies allow you to measure any element placed in the digital twin in order to proceed with the macro logic. Renishaw and Bloom are both supported, so you can guarantee that your machine is moving exactly like the real one will be, whether it's in-process dimension checking or even before the official program has begun. There are several ways to view the material removal simulation inside the NC Simul machine digital twin. All of the following can of course be done in either table or full machine view or even simultaneously. Inside the simulation ribbon and under the play button, you will find a drop-down menu with the various simulation types. Continuous simulation is the default, which will simply execute the G-code as stated until it reaches the end of the program. It's good for viewing the process for the first time or doing a final verification before greenlighting the operation. The next item in the dropdown is Break option. When active, the simulation will automatically stop on any parameters that you specify. These can be things such as collisions, specific ISO codes, a volume limit, or manual brakes that you've inserted into NC Simul. This mode is best for troubleshooting the program as it progresses. Next is End blocks, where you can specify the number of blocks that are run before the simulation pauses automatically. This is useful to slowly progress through the program without having to play pause or set a lot of manual breaks. Then we have Tool Selection, which simulates up into the next tool change sequence. You can utilize it to see the toolpath wireframes per sequence individually, or perhaps to see which offsets are being used for which sequence very quickly. The one below that is Comparison, which will run a complete continuous simulation and then automatically launch the comparison tool, highlighting the differences between the original part model and the resulting rest stock from the executed G-code simulation. And finally, there's the 3D Movie Creator, which when run to completion stores the material removal in the PRJ file so it can be used with the NC Simul player and distributed license-free across the shop floor for everyone to simulate and view. By utilizing all these different tools at your disposal and knowing when to do so, the material removal, troubleshooting, and validation of the process becomes extremely simplified with NC Simul.